Okay, let's give you guys some more practice. So this is a famous limit that you should recognize. So find the limit of this as x tends to infinity. So as x tends to infinity, find the limit. And this is very similar. Once you know how to do this, then you should be able to find the limit of this. Well, in this video, find the limit of this as x tends to infinity. As x tends to infinity, find the limit. So press pause and have a go. Okay, so to find the limit of this, let's just say the limit is y. Let's just say the whole limit is the number y. Now take the natural log of both sides. That will then give you this. So if you take the natural log of this, take the natural log of this can go down. That will then give you this natural log here, and then whatever's in here. So natural log of y equals this thing here. Now check. As x tends to infinity, this is going to head towards infinity. As x tends to infinity, if you look at this thing here, as x tends to infinity, this is going to be 0. So this whole thing here will be 1. So if you look at the natural log graph, it will look like this. 1 is here. So it's gonna, well, this block here will be 0. It's heading towards 0. So you've got a product here, infinity times 0. So whenever you have a product, you can always rewrite it as a fraction. So visualize this multiplying with this as a fraction. So rewrite it as this, one thing divided by this thing here. One thing divided by this thing here. Avoid putting this at the bottom because it will really complicate things. Try and get it on top. You could always rewrite this to be at the bottom, but avoid that. Try to keep it on top. So now we would rewrite this product as a fraction. Now let's check again. As x tends to infinity, this thing here, as x tends to infinity, this thing here will be 0. As x tends to infinity, this thing will head towards 0. And then as x tends to infinity, this thing here will be 0. 0 plus 1 is 1. 0 plus 1 is 1, and then take the natural log. Well, it's heading towards 0 here, so you've got 0 over 0. Well, 0 over 0 is an indeterminate form. If it's an indeterminate form, then we can use L'Hopital's rule. So differentiate this. That will then give us this whole thing here, because if you visualize this thing as natural log of the bubble, when you differentiate this, it will be 1 over the bubble, which is this bit here, and then times the derivative of the bubble itself, which is when you differentiate that, it will then give you this. And then differentiate this, that will then give you this. So once you get to this stage, it's just a matter of tidying up. So here you've got a fraction multiplying with a fraction, top times top, bottom times bottom. That will then give you this. Now visualize this as, well, you've got one thing divided by another thing. So visualize it as one thing multiply with the reciprocal of this, which will be this. So now it's just a matter of tidying up now. So these two will cancel out, and then the x squared will cancel out with this x squared, leaving you with this. So now as x tends to infinity, this is going to be 0, this is going to be 1, you're going to get 1 over 1. So as x tends to infinity, this whole thing here will be 1. So earlier we said natural log of y equals 1. So now e equally to both sides, that will then give you this, and in a way these two cancel out, giving you this. So our limit is actually e. So if you look back at the original graph, as x tends to infinity, it is heading towards that famous number e. So this thing here is somewhere around here is e. And now you can use the same technique to work out the limits of this. This is heading towards something. Okay?